What if I told you that our entire existence, every person, every tree, and every ocean, was born from a single unknown sound? We look up at the night sky and see silence. But what if our universe, where sound cannot travel, is actually full of noise? Secret songs that our scientists have recorded from the distant planets. Welcome. Today, we're going to uncover how that silence speaks. But first, the basics. Our entire universe began with a massive explosion billions of years ago. It continues to expand, but over billions of years, stars formed within it, then galaxies and our solar system. The Sun, the giant ball of fire, is the heart of our system. It is so huge that it could fit over 1 million Earths inside. Its incredible gravitational pull is what keeps all the planets orbiting it, each one with a mysterious story of its own. Under the Sun's power orbit are 8 major planets, which we divide into 2 groups, the inner rocky planets and the outer gas giants. In this long-form documentary, we will get to know each one, their strangest facts, their known secrets, and the details of their composition. And the most important part, as we finish the story of each planet, we will pause and listen to it. The planet's magnetic fields emit radio waves. These are like the planet's heartbeat. We will listen to those heartbeats. Prepare for a journey where physics meets the mystical. We are starting with our first stop, Mercury. Our journey begins by flying toward the Sun, to the planet that circles our star faster than any other, Mercury. This tiny world, barely larger than Earth's moon, is the marathon runner of the solar system. It zips around the Sun at over 107,000 miles per hour, completing one full orbit, its entire year, in just 88 Earth days. Because Mercury has almost no atmosphere, it is a planet of incredible extremes. On the side facing the Sun, temperatures can reach over 430 degrees Celsius, hot enough to melt lead and instantly vaporize anything organic. But here's the unbelievable fact. With no atmosphere to hold the heat, the shaded side plummets to a bone-chilling minus 180 degrees Celsius. This makes Mercury the planet with the most extreme temperature swings in the entire solar system. Given these extremes, the biggest mystery of this scorching planet is the confirmed existence of water ice. How can ice survive on the closest planet to the Sun? Scientists believe that in deep craters near Mercury's poles, sunlight never reaches the bottom. These permanently shadowed regions act like massive frozen traps, keeping ancient water molecules safe from the Sun's brutal heat. Here's a final strange twist. If you were standing on Mercury's equator, a single day, from one sunrise to the next, would last 176 Earth days. A Mercurian day is actually longer than its year. Now, let us listen. While Mercury's magnetic field is weak, it still captures the Sun's solar wind, creating a fascinating sonic signature. This is the recorded heartbeat of the fastest planet in our system, gathered by the NASA Messenger mission. From this small world of extremes, we move on to its near neighbor, a planet that at first glance looks like Earth's twin, but is actually a catastrophic atmospheric nightmare, Venus. Leaving Mercury's scorching heat, we arrive at its neighbor, Venus. Known as Earth's twin due to its similar size and mass, Venus hides a catastrophic reality beneath its beautiful, bright clouds. These clouds are not water vapor. They are made of sulfuric acid. Venus is the true oven of the solar system. Its dense atmosphere, made mostly of carbon dioxide, traps heat in what is called a runaway greenhouse effect. This makes Venus even hotter than Mercury, with a constant surface temperature of over 475 degrees Celsius. Here is one of Venus's strangest facts. It rotates in the opposite direction from almost every other planet. This is called retrograde motion, and it rotates incredibly slowly. A single Venusian day lasts 243 Earth days, making its day longer than its 225-day year. The pressure on the surface of Venus is crushing. It is 90 times greater than the pressure here on Earth's sea level. Standing on Venus would feel like being 900 meters deep in Earth's ocean. Any probe sent there only survives for a matter of hours before being crushed and melted. If you could capture the sound waves generated by its incredible, thick, chaotic atmosphere, what would it sound like? NASA's Pioneer Venus mission gave us some clues, recording low-frequency plasma wave data. From this planetary hellscape, we move to the next world in line, the one place we know life not only survives, but thrives: Earth. After visiting the scorching extremes of Mercury and the toxic atmosphere of Venus, we arrive at the one world that has defied the odds: Earth. From space, it is a swirling marble of blue and white, home to liquid water, complex chemistry, and over 8 billion people. But what makes Earth truly unique is not just the water, it is its invisible shield. Deep inside the planet, the movement of molten iron in the outer core generates a powerful magnetic field known as the magnetosphere. This field is absolutely vital, deflecting the deadly solar wind and cosmic radiation that would otherwise strip away our atmosphere and sterilize the surface. Earth is perfectly placed within the sun's Goldilocks zone, the ideal distance where temperatures are neither too hot nor too cold, allowing water to exist permanently as a liquid. This perfect placement, combined with the presence of plate tectonics to regulate the planet's temperature, created the conditions for life to flourish over billions of years. If Earth has such a powerful magnetic shield, what does it sound like? The interaction between our magnetosphere and the solar wind creates a fascinating sound known as chorus. It is the most beautiful and musical sound in the solar system, often heard in the region that creates the aurora. Having appreciated our unique home, we now leave our blue sphere for a world that perhaps resembles Earth's own ancient past. A dry, rusted, but tantalizing possibility for life: Mars. Leaving our thriving home, we arrive at the red planet, Mars. This smaller, colder world has captured humanity's imagination for centuries. A single Martian day, called a sol, lasts just over 24.5 Earth hours. However, orbiting farther from the sun, its year is much longer, lasting nearly 687 Earth days. Mars is red because its surface is covered in iron oxide, essentially rust. Its average temperature is a chilling -63 degrees Celsius. But despite this cold, evidence is overwhelming that Mars was once a warm, wet world. Ancient riverbeds and deep mineral deposits all point to the existence of vast oceans that covered the planet 3 to 4 billion years ago. So where did the water go? It's largely due to a cosmic tragedy. Mars lost its protective shield. Unlike Earth, Mars's core cooled down. This caused its strong magnetic field to collapse. Without that shield, the solar wind stripped away Mars's atmosphere, drying the oceans and turning it into the cold, desolate desert we see today. Despite being desolate, Mars is home to the tallest mountain in the entire solar system, Olympus Mons, a colossal shield volcano. The planet also experiences massive, planet-engulfing dust storms that can last for months at a time, completely obscuring the view of the surface. Listening to Mars is unique because it is the only world where we have an actual microphone on the ground. However, the atmosphere is so thin, less than 1% of Earth's density, that sound is very faint. The audio we hear is the low-frequency rumble of the Martian wind and atmospheric shifting. Leaving the rocky inner worlds behind, we cross the vast asteroid belt. We are now heading toward the first of the gas giants, a planet so large it could swallow every other planet combined: Jupiter. After crossing the asteroid belt, we enter the outer solar system and meet the undisputed king of the planets, Jupiter. This colossal giant is so large that it contains more mass than all the other planets combined, nearly 2.5 times more. You could fit over 1,300 Earths inside it. Despite its massive size, Jupiter rotates faster than any other planet. A single Jovian day lasts less than 10 Earth hours, leading to incredibly strong, chaotic weather systems. The most famous is the Great Red Spot, a massive storm larger than Earth that has been raging for at least 350 years. Jupiter is a gas giant, meaning it has no solid surface. It is composed primarily of hydrogen and helium. As you descend, the pressure is so intense that the hydrogen eventually gets squeezed into a bizarre state called metallic hydrogen, a material that behaves like a metal but flows like a liquid. Jupiter possesses the strongest magnetic field of any planet, nearly 20,000 times stronger than Earth's. This immense field creates a massive radiation belt surrounding the planet, so intense that it would instantly sterilize any unprotected spacecraft or human. It is this immense magnetic field and its radiation belts that create one of the most stunning and powerful sounds in the cosmos. Scientists, using the Voyager and Juno missions, have captured the massive, complex radio emissions generated by this magnetic giant. From the solar system's colossal king, we now journey to the planet most famous for its elegance and mesmerizing structure, Saturn. Leaving the colossal power of Jupiter, we move on to the most recognizable planet in the entire solar system, Saturn. Famous for its stunning, intricate ring system, Saturn has long captivated astronomers and artists alike. It truly is the jewel of the cosmos. Saturn's signature feature, the rings, are not solid structures. They are made up of billions of pieces of water ice, dust, and rock, ranging in size from tiny grains to massive boulders. These rings are spread over a distance of 280,000 kilometers, but are incredibly thin, only about 10 meters high in most places. Saturn is a true paradox. It is the second largest planet, yet it has the lowest density of any world in the solar system. It is so light that if you could find a giant bathtub filled with water, Saturn would float. Like Jupiter, its composition is mostly hydrogen and helium. Despite its serene appearance, Saturn is a turbulent world. Its day is incredibly short, lasting only about 10.5 Earth hours, creating fierce winds that can reach speeds of over 1,600 kilometers per hour. And at its north pole, it hosts a giant, permanent, hexagonal storm pattern, a bizarre, six-sided feature still being studied by scientists. Saturn also possesses a tremendous magnetic field, creating a radiation environment that is 1,000 times less intense than Jupiter's, but still powerful. NASA's Cassini mission spent years studying this environment and recorded the intense radio emissions created by the planet's magnetosphere. From this gorgeous ring planet, we move to the distant, icy frontier of the solar system, to a world that orbits on its side, Uranus. Beyond Saturn, we reach Uranus, the first of the two ice giants. This planet is a pale, nearly featureless blue-green sphere, primarily composed of a thick layer of water, methane, and ammonia ice swirling around a small, rocky core. It's one of the coldest worlds in the solar system. Uranus's most baffling feature is its extreme axial tilt. While other planets spin upright like a top, Uranus is tilted by nearly 98 degrees. It essentially orbits the Sun, lying completely on its side. Scientists hypothesize that this may have been caused by a massive collision early in the solar system's history. This unusual tilt causes the most extreme seasons imaginable. Since its poles sometimes point directly at the Sun, one pole can experience continuous sunlight for 42 Earth years, while the other pole endures 42 years of complete darkness. Uranus is extremely distant from the Sun, making its year painfully long. One full orbit takes the planet nearly 84 Earth years. The average temperature on Uranus is bitterly cold, around -200 degrees Celsius. Like its giant neighbors, Uranus has a complex magnetic field, though it is strangely tilted and offset from the planet's center. The Voyager 2 probe was the only mission to get close enough to capture its unique radio emissions. From this tilted ice giant, we make our final major jump to the most distant planet, Neptune. Our planetary journey reaches its end at the most distant and mysterious major planet, Neptune. Orbiting at nearly 30 times the distance between the Earth and the Sun, Neptune is a deep, striking blue, a color derived from the methane in its atmosphere. Despite its extreme distance and frigid temperatures, averaging around -210 degrees Celsius, Neptune is the most dynamically violent planet in the solar system. It experiences the fastest sustained winds ever recorded, with gusts tearing through the atmosphere at over 2,100 kilometers per hour. Neptune takes an astonishingly long time to complete a single orbit. One Neptune year lasts nearly 165 Earth years. Since its discovery in 1846, Neptune has only completed a single orbit around the Sun in 2011. Like Uranus, Neptune is an ice giant composed primarily of water, ammonia, and methane ices. It emits more internal heat than Uranus, suggesting greater internal activity, which helps drive those ferocious winds and storms. Neptune's magnetic field is also tilted, and like Uranus, the only spacecraft to gather detailed data was the Voyager 2 probe. It detected low-frequency plasma waves and bursts of radio noise generated by the planet's powerful magnetic interactions. We have now traveled from the inner sun-scorched rock to the outer frigid giants. But the exploration doesn't end here. Beyond Neptune lies a vast, mysterious frontier filled with dwarf planets, comets, and perhaps the key to how our solar system truly formed. We began our journey at the sun-scorched rock of Mercury and traveled across 4 billion kilometers of space. We flew past the toxic oven of Venus and our vibrant, protected home, Earth. We saw the rusted deserts of Mars and sailed through the massive turbulent atmospheres of the gas and ice giants, Jupiter, Saturn, Uranus, and Neptune. But our biggest discovery wasn't just in the sights, it was in the sounds. Every world in our system creates a unique signature, a complex song of magnetic fields and charged particles. From the sharp chorus of Earth to the deep rumble of Jupiter, we have heard the hidden cosmic symphony that plays across our solar system. These aren't just planets, they are vibrant, active, talking worlds. Yet this is just the beginning. Beyond Neptune, the Kuiper Belt and the Oort cloud await, holding billions of icy relics that tell the story of creation itself. Humanity's quest to understand the universe continues every day, powered by curiosity and the spirit of exploration. As we conclude this cosmic journey, we have one critical request. If you are fascinated by the secrets of our solar system, please like this video. Your support immensely encourages us and helps us continue exploring the unknown. And be sure to subscribe to our channel. And as we prepare for our next great leap, tell us in the comments, what other interesting space topic would you like to see a video about? Join the journey. Thank you for watching.